Today we're going to talk about the properties of logarithms. The first one we're going to talk about is called change of base. It's a way to use your calculator to do bases other than the two that it is programmed to do. So if we look at our calculator, it is programmed to do base 10 logs using this key, log. And even though no base is written, it's implied to be base 10. It's also programmed to do base E logs, so natural logs. But it's not programmed to do base 3 logs or base 5 logs or base 7 logs unless it's an advanced model. Some of those are programmed to do any base, but the older models are only programmed to do base 10 logs and natural logs. So how do we answer a question like log base 3 of 10? Well, we know hopefully we know, log base 3 of 9 would be 2 because 3 to the second is 9. So this answer is more than 2, but it's not clear exactly what it is. So we can use change of base. Now change of base says this in general. Log base b of x can be done on a calculator as the log of x over the log of b, or as the natural log of x over the natural log of b. Notice the x is here and the b, it's like the natural log or the base 10 log of the base. This is purely a calculator thing. Most of the time we do not divide logs by logs, but to get the calculator to do work, this is a way to get that to happen. So for this one, if I wanted my calculator to do it, I could type in the base 10 log of 10, the base 10 log of 3, or the natural log of 10 divided by the natural log of 3. So let's see what that is. I could type it in as log of 10 divided by log of 3. And that gives me about 2.096. Just to show, if I had done natural log of 10 divided by natural log of 3, I would have gotten the same answer, about 2.096. So definitely a number slightly more than 2. If I wanted to do log base 9 of 256, again, I don't know what that is. I could do this as log of 256 divided by log of 9. Log of 256 divided by log of 9. Okay, and that's about 2.524. Okay, so this is just, change of base is just a way to get your calculator to compute things that we can't do with mental math. The other properties that we're going to talk about today have to do with expanding logarithms, and they're based on the properties of exponents because there are strong ties between logarithms and exponents. So the log base b, so whatever that base is, of the product x times y could be expanded as log base b of x plus log base b of y. So sometimes if you think about this as if the base is the same and you have a product, you add your exponents. So a product expands into a sum, which logically that might lead you to believe, and it is true, that log base b of a quotient, x divided by y, expands into a subtraction problem, a difference. Because if the base is the same in a division problem, you subtract your exponents. This property says that if you have a power um, in a log problem, you can actually bring that power out in front. So the expansion would look like a times log base b of x. And tonight's homework has practice with these things, so let's practice them. So if I have log base 3 of 10x, that's a product, 10 times x. So I could say that's log base 3 of 10 plus log base 3 of x, and I'm done. There's nothing else I can do. I want to compare that to log base 3 of 9x, which would be log base 3 of 9 plus log base 3 of x. And log base 3 of 9, unlike log base 3 of 10, which I don't know, log base 3 of 9 is actually the number 2 because 3 squared is 9. So I could take this one step farther and evaluate a piece of it, the numerical piece. The algebraic piece has to stay. Okay, log base 5 of y cubed over 25. We have a power and we have a division. Hopefully logically you're seeing this as I'm going to break this based on the division first because the power only applies to the numerator. So we're going to call this log base 5 of y cubed minus log base 5 of 25. Okay, now we can use that property that says a power can pull out in front. So we're going to have 3 log base 5 of y minus, and now I'm going to ask the question, do I know this? Log base 5 of 25? Indeed, that's also 2 because 5 squared is 25. Natural log of the quantity x plus 3 squared. The condition x is greater than negative 3 just refers to the domain of this, because if x were anything smaller than negative 3, we'd be putting 0 or a negative number in here, which is not allowed. It's not in the domain of natural log. So I can bring this power out in front. So 2 natural log of x plus 3. And sometimes people get fooled and they think, oh, it's a sum. I'll write this as natural log of x plus natural log of 3. That's saying that the distributive property applies to natural logs, and it doesn't. The only time we can expand is if we have a product or a quotient, not a sum. So that problem is actually done. Natural log of the square root of x over y cubed. It's a quotient, so natural log of the square root of x minus natural log of y cubed. Each of these has a power. Remember that the square root is the 1/2 power, so we can bring that 1/2 out in front, and we can bring that 3 out in front. Okay, here are some problems involving numbers where the directions will tell you you can simplify these without a calculator. So log base 3 of 9 to the 1.2 power. And you might say, well, I don't know what the 1.2 power of 9 is, but the expansion properties say I can pull that out in front. 1.2 log base 3 of 9. And we should know log base 3 of 9 is 2 because 3 squared is 9. So now I've got 1.2 times 2, which, good mental math, is 2.4. Log base 5 of 75. Well, 75 is not good, but 75 is 25 times 3. And I know 25 is good for 5. The numbers that are good for base 5 are numbers like 1, 5, 25, 125, 1/5. So now that I've written this as a product, I can expand it. Log base 5 of 25 plus log base 5 of 3. Log base 5 of 25 is 2. Log base 5 of 3 is not good, so I'm going to leave that. That's nothing I could know. But just like when we simplify square roots, you know, like the square root of 20, and we say, well, the square root of 20 isn't perfect. But there's a 4 in there, and so we can call this 2 square root of 5. That's the same logic I'm using with this problem right here. Base 5 log of 75 is not good, but there is something good in there. There's a 25. Okay, and again, this strategy, similar to the one we did over here, I can pull the 8 out in front, 8 natural log of e, and the natural log of e, remember, there's kind of the implied base e down here. So e to what power would be e? That would be 1, because e to the first power would be e. So this problem is really just 8 times 1, or 8. Okay, so there are some problems to try in the homework, and we'll talk tomorrow.